Plate tectonics and Earth's features. How does the topography of the ocean floor compare to land? Hook. Radioactive decay. For this hook, you will need the student handout, Radioactive Decay, a computer, and various supplies for students to use to create a model of radioactive decay. Students will work with groups to create a model of radioactive decay in 5 minutes, then present their models to the class. Do 1 activity, modeling plate movement. Students use a model to observe lithospheric plate movement and the resulting landforms. For this you will need the student handout, Modeling Plate Movement, and the following materials. For each student, use the knife to score each full cracker sheet down the middle of the cracker. After scoring, break it apart on the lines so that each student receives 1 large piece and 2 small pieces on a paper plate. Explain to students that the 2 small cracker pieces represent lithospheric plates of Earth. The marshmallow fluff represents the asthenosphere layer of Earth. Students will draw and label the crackers and marshmallow fluff in the lab journal. Students will spread a heaping tablespoon of marshmallow fluff on the large cracker and place the 2 smaller pieces on top. For transform boundaries, students will slide 1 cracker one direction and the other cracker in the opposite direction, then diagram the model. For convergent boundaries, students will move the 2 small graham crackers toward each other so that they form a small upside-down V on top of the marshmallow fluff. They will then diagram the model. For divergent boundaries, students will move the 2 small crackers away from each other so that they are slightly separated on the marshmallow fluff. Then diagram the model. Have students model another type of converging plate movement by pushing 1 graham cracker a little under the other graham cracker when they meet. They will then diagram the model in the lab journal. Do 2 activity, how tectonic plates move. Students observe a model of the mechanism of tectonic plate movement and develop a model based on evidence of the movement of tectonic plates by thermal convection. For this you will need the student handout, How Tectonic Plates Move. Students will also need the following materials. Cut 1 15 by 15 centimeter sheet of foil for each group. Be prepared to review lab safety rules regarding using a heat source and glassware. The students will be boiling water as part of the model. Students will use the base of a 500 milliliter glass beaker to trace a circle on a piece of aluminum foil. They will then fill the beaker with 300 milliliters of water and place it on a hot plate. Students will cut out the circle of foil and cut the circle into multiple pieces, no smaller than 1 centimeter square, keeping the pieces as flat as possible. Students will then float the pieces of foil on top of the water, trying not to overlap the pieces as much as possible. Students will turn the hot plate on high to boil the water and record what happens. They should observe the foil as the water begins to heat. Then they will turn off the hot plate, allow the beaker to cool before removing it from the hot plate, and stop recording once the foil pieces are no longer moving. Students will record their observations of the model and draw a series of labeled and captioned diagrams describing what occurred in their lab journals. For Part 2, have students create a 2D model based on evidence of the movement of tectonic plates by thermal convection and display it as a part of a slideshow presentation explaining the mechanism that creates plate movement. Do 3 activity, radioactive decay. Students model the half-life of radioactive elements that represent a major source of Earth's heat. For this you will need the student handout, Radioactive Decay, the student reference sheet, Rate of Carbon-14 Decay, and the following materials. Label one bag for each group as carbon-14 atoms and place 100 pennies in each bag. Label a second bag as nitrogen-14 atoms for each group. Students will count the pennies to determine the starting number of carbon-14 atoms within the sample of the element, then label this number as energy-releasing event number 0 in their data tables. Students will shake the carbon-14 bag twice and pour the pennies onto the table. Remove all atoms with tails up and place in the bag labeled nitrogen-14 atoms, as they represent decayed atoms. They will count both atom types and record the numbers in their data table under energy-releasing event number 1. Students will repeat this process until all carbon-14 atoms have decayed into nitrogen-14. Do 4 activity, plate movement over time. Students observe models of the Earth's land masses and oceans for various geologic time periods. For this due, you will need the student handout Plate Movement Over Time, and 2 computers with internet access, and a set of colored pencils. Locate the collection of maps needed for this task by searching for the Paleo Map project and choosing the Earth History section. Have students view each map, then take notes and draw a diagram reflecting on each time period's conditions. Students will then write a scientific explanation about the role of tectonic plates on Earth's condition. Do 5 activity, hotspot volcanoes. Students determine how fast tectonic plates move based on hotspot volcanism using maps. Then determine the speed the plates were moving between each volcano and the average speed for each plate. For this due, you will need the student handout, Hotspot Volcanoes, and the student reference sheet, Maps of Hotspots. Students will also need the following materials. Students will record the distance between the midpoints and calculate the approximate age differences of the major Hawaiian islands, the midpoints of the Galapagos Islands, and the locations of Yellowstone volcanoes and calderas on each hotspot map. Students will then calculate the approximate speed at which the crustal plate was moving between the times that each of the features formed. Do 6 activity, Plate Tectonic History. Students read a text and discuss the roles of evidence, technology, various fields of science, and engineering in developing the theory of plate tectonics. For this due, you will need the student handout, Plate Tectonic History. Students will also need their lab journal.